MB का डेटा रख सकते हैं. So this is how you can utilize the actual process. So virtual memory, which implies demand paging, demand segmentations, are both used in almost all operating system today. So here you can see, so this is the virtual, this is the disk memory, that is the virtual memory which we are utilizing, and this is the actual मेन मेमोरी. तो ये एग्जांपल में हमने देखा कि अगर ऐसी कोई ऐसी रिक्वायरमेंट है जहाँ पर मुझे 30 MB का 30 MB की रिक्वायरमेंट है मेमोरी की. सो व्हाट आई विल डू इज आई विल टेक 10 MB of data, which I will give it into the main memory, and 20 MB I can put it into the disk for accessing or for processing. So this is how we can do the virtual memory use. So here they have given, they have specified all the things what virtual memory can do. If a piece is not in the memory and is required, processor generate interrupts. तो अभी आपको पता है that whenever if you demand something and it is not available in the memory or in the any area of the program, so at that time various interrupts are generated by the operating systems. Okay, sorry, by the process, and the operating system has to take care of whatever interrupts are generated. The operating system will take care of it. So in this case, the operating system might block that state or might exit that process, or it may reschedule the time for execution of that process. Okay, so virtual memory and virtual machine. So what advantage of having only a portion? Okay, so here virtual memory का ये आगे पेज में है virtual memory. Okay, now advantages of having only one portion, that is more process in the memory at a time with increase in the speed throughput with no increase in response time. And see, whenever why we are doing all these things, as every nano, or you can say every second n number of process comes for the execution, but every process is not entertained. So why, so that for that purpose we do the process management, and through process management all the process are managed, but again they are managed. So every process they are which is managed will require a memory for execution, so that is why we are going through this. So though this process is getting the process management, and they are being given the time for execution, but it will require space. So we, as the process number is increases, it doesn't mean the throughput of the machine is going to get increased. We will have to manage all these things. So how to do all these things? So see, uh, whenever we were working for virtual memory, on virtual memory, so we need to work through the यहाँ पे ये virtual memory, it is actually on the disk, and we have to take access of that, that is on not on actual basis, on the logical basis. So that is the concept what we have to create here. So how it is done, that we have to see. So see, here what we are going to do, this is the operating system, here is your memory. So we will load that memory instruction. Okay, then operating system will trap it. Okay, then what operating system will do, page is on backing store, so what it will store that page on some back storage. Okay, then from that back storage, whenever it is required, that page, that time only it will bring it into the memory. अब ये ऐसा प्रोसेस होता है, लेकिन मान लो अब जब आप मेन मेमोरी में क्या होने वाला है, आपका मेमोरी डिवाइड होने वाला, सॉरी आपका वर्चुअल मेमोरी में क्या होने वाला है, योर कंप्लीट program which I told, it is divided, like some half will be on the actual main memory and some half will be on the will be present on the virtual memory. So to how whenever the processor is processing that particular program, and if it doesn't find certain frame which is required for certain frame means certain part of that program which is required for the execution, because it is not available at that time, it will generate a error, and that error or uh, that concept is known as page fault. So in this case, what we have to do, we have to organize the system in such way that we can handle this generated page fault. So how we can handle is that every time you load a part of the memory, you keep a frame on that particular part in a backing storage. And whenever we find that any of the space of the memory is free from the physical memory, we just bring that uh, frame into the main memory, and you give the acknowledgement to into the page table, so that whenever that part of the memory is required, it can be trapped by the from the page table. Okay, so paging, this is how we can handle the page fault. Okay, so here are the issues, that is pieces is thrown out just before it is used. So it might happen that if suppose free this frame was free, so I just swapped in the page which was available in the back store. But as against certain different frame is coming, I will swap this frame out. But whenever it was required at that time, that frame is not available. So that is this point. It is thrown just before it is used. Go get that piece again almost quickly. So immediately now, अगर ऐसी केस होती है, so it is required, so again we have to, the operating system has to take that particular page again in. So this leads to again a problem that is known as caching. So solution for that is that OS tries to guess which keys are least likely to be used in near future. Again, certain algorithms are used, and this problem can be solved by using those algorithms, by utilizing whichever pages are required to be kept into the store, and whichever in the memory, and which are not actually required for say some more period of time, so that can be through that can be uh, and that page table will be having the entry of its virtual address with the offset. So virtual address is again divided. This is the logical address which is divided into page number and the offset address. Here the page table entry will have the P and M bit, that is modified bit and present bit with the frame number. Okay, so these are the protection policies you have to go through. So this is how your process will be divided into the pages. Page table will contain the information about the frame numbers and the bit which will specify whether that bit is whether that frame or the page is valid or not. And then this is the main memory. So according to the requirement, this main memory will be filled, and बाकी का जो process है वो यहाँ पे virtually हो जाएगा. Okay. So demand paging is similar to what we have learned in the swapping. Okay, so it will contain a disk space. So whichever pages are required on that demand, only that pages will be in the main memory. Like say this is the part of the program which is currently executing. तो ये part अभी halt में है ना, इसके पेजेस तुरंत बाहर जाएंगे, इसके इन किए जाएंगे, सो दैट इज नोन एज ऑन डिमांड। तो दिस जितना ये सिंपल लग रहा है इस डायग्राम में, इतना सिंपल है बिकॉज वो यहाँ से फिजिकली नहीं उसको रिमूव करना है, वी जस्ट हैव टू टेक दैट इंस्ट्रक्शंस एंड पुट इट बैक इनटू द डिस्क, बट द एक्चुअल एड्रेस स्टेज देयर। सो यहाँ पे एड्रेसिंग का बहुत कॉम्प्लिकेटेड, कॉम्प्लिकेशन नहीं बोल सकते, बट दैट वी हैव टू कीप द रिकॉर्ड। So here this address translation is done, that how you take that frame from that particular main node and get it into the main node. So from here it is picked up and how the address, पहले तो लॉजिकल एड्रेस कैसे बनता है, फिर लॉजिकल से उसको फिजिकल में कन्वर्ट करने के लिए आपको ऑफसेट लगेगा, फिर वो ऑफसेट ऐड होने के बाद आपको एक्चुअल स्पेस उस प्रोग्राम के पार्ट की मेमोरी में मिलेगी, मेन मेमोरी में मिलेगी। Okay, so all about what you know, need to know about the page tables, the page table information. Then again, like your PCB, that is the process control block, we have your translation look aside buffer, which keeps the record of all the table, all the record of the virtual memory and the their addresses and every information which requires to process this. तो इसमें ये सारी इंफॉर्मेशन है। ओके, this is how your translation look aside buffer works. So I will explain you this diagram only. Okay, so here the CPU checks the TLB. TLB is what? Translation look aside buffer. So translation look aside buffer contains all the information. Okay, I'm not reading all these things because it is simple to understand. देखो, अगर आप कोई पेजिंग कंसेप्ट कर रहे हो तो आपको उस कंसेप्ट है तो उसके रिलेटेड जो भी स्टोरेज लगने वाला है वो तो चाहिए, लेकिन उसको फॉलो करने के लिए आपको कुछ रिकॉर्ड्स मेंटेन करने पड़ेंगे। जैसे है, जैसे मैंने बोला है आपको पीसीबी होता है, सिमिलरली यहाँ पे भी आपको क्या लगेगा, टीएलपी लगेगा, because this thing is very easy to look, but actually internally it happens in very deep way. And each point, each address, each pointer pointing that particular field is to be noted, because there is a jumping of flow from one space memory address to other memory address. So that is why you need all these things. Okay? So here it will check whether it is available in the TLB or not. So if it is yes, तो यहाँ पे जाएगा, तो TLB अपडेट करेगा। Okay, so just go through it. If you don't understand, it is very simple to understand. ये डायग्राम से ज़्यादा इजी है मुझे ऐसा लगता है। Don't go for it. TLB कैसे वर्क होता है? Okay, now only from this unit, what I feel is almost आपका सब कवर हो चुका है। ये थोड़े से चीजें हैं, इट इज ऑल अबाउट थेरोटिकल पार्ट है। ओके, सो फ्रॉम दिस यूनिट आई डोंट थिंक सो, थोड़ा सा थेरोटिकल पार्ट है, दैट यू कैन डू फ्रॉम योर साइड ओनली। Okay, if you have face any problem, you can come back and you can ask to me. Okay, so I think more than enough we have discussed. So if we go back and if I discuss the some this what you can say the unit. The main points here is that you should understand why memory management is required, how field system does it, and these are the methods which we have discussed. So, what is the role of paging, fragmentation, segmentation, and very important. This is known to you,
मग
okay?
माझं काय सांगता का तुम्ही
Then the
मला
next is virtual memory. तो virtual memory का translation leukocyte table important है, ये कैसे generate होता है, वो virtual
मग
address.
कोडाचा उपयोग करून मग बजाजवाल्याकडे
Okay,
जाणार
then virtual memory with segmentation
कुठं
and virtual memory with paging. So this is all about your
नालायला ना
6
खरंच
unit.
गव्हर्नमेंट
So
यायला
one two points,
जमत नाही
you do it by yourself. Yeah, it is
बजेट
under
मध्ये मी
readable and it is mentioned in the PPT. Okay.
मिळाला
So
नाही
if you face any
येणार आहे
problem, anytime you can come
सगळं
or you can ask me, you can message me. Okay. तो अगर आपको कुछ डाउट है तो आप भी पूछ सकते हो.
मागचा एक
Okay,
महिना
I would
झाला
have continued, but I am not able to speak only. Okay. So any doubt you have from your side?
नाही ना आणि आता आलो नसतो का मी UTIच्या ठिकाणी आलो नव्हतो का
Okay, no doubt. So shall I leave the
अच्छा जर
lecture?
तुम्ही मला अजून उद्या कॉलेजला बोलवलं उद्या टेस्ट आहे उद्याचं बी तयारी करायची अजून
Okay. Thank you.
Thank you, ma'am.